Okay, so this week we'll finish up with lines today, and on Tuesday of next week we'll have a quiz on Monday. If your grade is below 70%, you need to come in. If not, you are good. And we will do we'll finish up chapter 2 with absolute values on Wednesday, and then we will start chapter 3 on Thursday and Friday of next week, so that we can spend all of the week after that working on the test. So your test will be 2 weeks from yesterday. That's because there's no school 2 weeks from tomorrow, or 2 weeks from today, sorry. There's also no school 2 weeks from tomorrow, but that's because it's a Saturday. So 2 weeks from today, there's no school, so we'll have the test the day before that. So you have Tuesday and Wednesday in 2 weeks to review. Next week we'll finish chapter 2 and start chapter 3. So your joke today from our friend Kaya Haas. She gave me a much better joke than I already had, and the joke is actually kind of scary. Whoever said, out of sight, out of mind, never had a spider disappear in their bedroom. If you are not a spider fan, that would be not very pleasant for you. But anyway, there is another one from Kaya coming on Tuesday. So, we've got 2 things to do today. We have linear functions and story problems. Modeling is just a way of saying story problems. And then we are going to evaluate and graph piecewise functions, which is everyone's favorite thing. Yeah?
Wait, it's 2.1. Are you excited?
So, this is all out of order because it wanted me to teach you story problems about lines before I taught you about lines. And I figured that was weird, and so we did all the other ones first, and now we're going back to it.
Okay.
So this is 2.1. The book just put it in a really weird order.
Okay.
And then we will go back to 2.5 on Wednesday. So, story problems. If we have a story problem dealing with lines, there are 2 numbers we will need to know. Because in slope-intercept form, there are 2 numbers we use. One of them is slope, that is the letter M. The other one is the y-intercept, that is the letter B. Okay? So, there are 2 numbers we need. Slope is our constant rate of change. We talked about that for a couple days last week. And rate of change are things like speed, or miles per gallon, your gas mileage, or toilets are measured in, it used to be they were measured in gallons per flush, and then they remade toilets so that they would save water, and now they have liters per flush. It used to be water would just rush out inside the toilet. Now they have the little whoosh thing that like pushes the water out really fast and washes everything away. Used to be you could put a gallon of water down every flush. Now you're only allowed like a liter or a quart. So they made them more efficient, but a little more noisy. So the flow rate in a toilet is less than it used to be, but it moves faster, but there's less water. So things like that with the word per, things that are changing, that is your slope, and then your y-intercept is your initial amount, your starting point. If you remember back to the problem about the guy driving in Texas, or away from Texas, he was 15 miles north of the border, that was his starting point, and he was moving 60 miles an hour, that was the rate of change, the speed. So he was going 60 miles an hour north, and he was starting 15 miles an hour. So every hour he went 60 miles further, but he started 15 miles an hour, 15 miles north of the beginning. So your initial amount, that's your y-intercept. Your rate of change, your slope, that is your slope, the number that goes in front of the x. So what you'll do is you'll be given a problem, and it'll ask you, you'll need to find what the slope is, you'll need to find the y-intercept, and then you plug them into this formula. F of x equals the rate of change times x plus the initial amount. And that will give you something that looks like slope-intercept form. Okay? So, your constant rate of change, that is your slope. Your initial amount is your y-intercept. Okay? So, there's going to be two types of problems in Delta Math today. One of them will say, it'll give you a paragraph to read, and it'll say, based on this paragraph, what is the equation of this line? And it will just give you the numbers for both of them. Another option is they might give you a paragraph and then a table, and you'll need to use the table to find either the slope or the y-intercept. We'll practice a couple of those here. Here is an example of one of those problems. There's a tank, it has 100 gallons in it. And every minute, 5 gallons is drained out of the tank. Okay? So 5 gallons a minute is the drainage rate, and 100 gallons is what we are starting with. Okay? It's got a couple questions for us. It's got 4. First, it wants us to write a formula. Second, it wants us to calculate how much water we would have after 4 minutes. Third, it wants us to graph the situation. And fourth, it wants us to talk about domain and range. So first thing we need to talk about is, what is the formula for this problem? Well, we have a rate of change, and we have a starting amount. Let's talk about the starting amount first. So, Shaylee Rowato, what is my tank starting with? How much water do I have in my tank to start? 100. So 100 is my y-intercept. And Kayla, what is my rate of change? How much is my water changing every minute? 5. And is it going up or is it going down? Down. So 5 is going to be negative. Okay? The problem doesn't say negative 5 here. You have to figure out from the problem that the amount of water you are having is going down, which is going to be a negative number. So that's a little trick you might want to look at closely. Make sure you know whether that number is going to be positive or negative. Because we're draining, drain means go down, that's going to be negative. Okay, so our slope is negative 5. Our starting amount is 100. So our problem is going to be y equals, or our formula, y equals negative 5x plus 100. And the reason it's negative is because we are draining, we are going down. Okay. So, next question, how much water is in the tank after 4 minutes? So we're going to plug in 4 in for x. So we'll go negative 5 times 4 plus 100. So Alyssa, negative 5 times 4? And negative 20 plus 100. So there are 80 gallons in the tank after 4 minutes. Okay. Now it wants us to graph that. Well, I have 2 points. I have a y-intercept, and I have a second point. That's pretty easy to graph. We'll do that right here. I know that I have 100 gallons at 0 minutes. I also know that after 4 minutes, I have 80 gallons. And I could draw that line right there and find where it crosses the x-axis. Okay. Now what we need to figure out, because it wants the domain and range, we probably need to figure out at what time would we run out of money, or run out of water, excuse me. So, Cole, if I've got 100 gallons and 5 gallons is coming out every hour, what's 100 divided by 5?
20.
20, exactly. So after 20 minutes, I will have no more water. So 100 gallons is where I started with, 0 gallons is what I end with, and that happens after 20 minutes. So after 20 minutes, we have no more water. Okay? So now let's talk about domain and range. Domain is going to be all of the amounts of time that I have water in that tank. So, Mason, what is the smallest amount of time I could have water?
A minute.
Could I have less than a minute?
Yeah, 0 minutes.
0, right? What's the most amount of time I can have water in that tank?
20 minutes.
20. So my domain is going to be from 0 to 20. That's my domain. Let's talk about our range. So Ashlyn, how many would I have? What's the most amount of water I can have?
100 gallons.
And what's the least?
0.
Because we can't have negative amounts of water. But I also can't put more water in than the tank holds. So 0 to 100 would be my domain, or my range. So 0 to 100 would be my range, that's the amount of water I can have. 0 to 20 is the domain, that's the amount of time that I can have water. So I can't have less than 0, I can't have more than 20, I can't have less than 0 because I can't have negative amounts of water, I can't have more than 100 because then it's going to overflow. Okay? So my domain is 0 to 20, my range is 0 to 100. And those are both brackets because I can have 0 time, I can have 20 minutes, I am allowed to have no water, and I'm allowed to have 100. I just can't have more or less than those. Okay? So,
If the water wise, you can have water for 20 minutes.
yeah. So, let's look at a delta math problem just like one you will see on your homework. In fact, I took this off of the homework. Some of you may actually get this one, some of you won't. They randomize them. So we've got Maya, she lit a candle. And her candle burns until it is all gone. And she kept track of how long the candle was after every hour of burning. After 1 hour, it was 3 inches. After an hour and a half, it was 2.5 inches. And after 3 hours, it was 1 inch. Okay? And what it wants to know is what was the original length of the candle. There are 2 things it could ask you. It could ask you for a slope, or it could ask you for a y-intercept. If it asks you for a slope, it's going to ask something like, how much does the candle burn every hour? So something about change, okay? If it asks you for where you started, the word starting, initial, or in this case, our keyword is original. That word right there, anything about starting point, initial, original, that tells you you're looking for a y-intercept. If it asks you for anything about change, then that means it's asking for a slope. This one's asking for a y-intercept. So the y-intercept, we need to figure that out. To find a y-intercept, we need a formula. To find a formula, we need a slope. Let's take 2 points from our table and find a slope. I like to pick numbers that don't have decimals in them. So we'll go 3 minus 1, that's these 2, over 1 minus 3. That's those 2. Leilani, 3 minus 1.
2.
And 1 minus 3?
-2.
And what does that simplify to?
-1.
-1. So -1 is my slope. So -1 is my slope. What that means is every hour my candle burns down 1 inch. So I'm cutting an inch off my candle every hour I burn it. There's 2 ways we could answer this question. We could just think about it and try to figure it out. Or we could plug this into point slope form. If you just wanted to think about it, you could say to yourself, well, at 1 hour I had 3 inches. So if I go backwards an hour, how many inches would I have? 4. That is our answer. Okay? You could do it that way, totally fine. The other way you could do it, or if it's a more complicated problem where that might not be so easy to do, we could plug this into point slope form. So I could take my slope of -1, I could take this point right here, I could plug it into point slope form, I would get y equals -1, x minus 1 plus 3. I could distribute the -1 through, I could get -x plus 1 plus 3 equals -x plus 4, and that would also be my answer, +4. Okay? So you can either think about it, kind of work backwards in your head, or you can plug it into the formula and figure it out from there. Okay, either way, the original length of the candle was 4 inches. Okay, so that's something like you might have. You got to look at the question at the end and figure out what's it asking for. Original, starting, initial. That's going to be y-intercept. And then if it says anything about change or what happens after 1 hour, that kind of thing, that'll be slope. Okay? And so you just calculate the slope. The answer would be -1. Okay. But this one asks for y-intercept. Our y-intercept is 4. So that's the first half of your assignment. We're going to take a break now, watch a really bad song involving a singing ketchup bottle, and then we will come back and talk about piecewise functions. I warn you, this one is really bad. The guitar player, he would deserve full credit on this one. The other two...
But there's nothing they can do to stop it. There's a new electric lighter out there, and it's got the firepower of...
Here we go.
Just like it sounds.
make yours better than that. However, the guitar was good. And maybe I'd give you bonus points for winning the ketchup costume. So, as he was trying to say, or they were trying to say, piecewise functions are functions that are broken into pieces. That is why they're called piecewise defined. Okay? So, piecewise functions are broken up into pieces, depending on the x values you are plugging in. Okay? So, if your function, you can have a function that's broken into 3 pieces, and there would be 3 different formulas depending on what x values you're using. Okay? So a function that is broken up into pieces based on its domain, or based on its x values, is called a piecewise defined function. We're going to do a special kind of piecewise defined function today that are all made up of lines. Okay? They're called piecewise linear functions. Okay? So piecewise linear functions are going to be little pieces of lines broken up along a graph. So on the left side, you might have a line with a negative slope. On the right side, you might have a line with a 0 slope. On the right side, you might have a line with a positive slope. Okay? So your different sides of your graph are going to have different shaped pieces of a graph. Here's an example of a piecewise function. It is called the Fujita scale. It's how we measure tornadoes. A F1 tornado has a wind speed of between 40 and 72 miles an hour. Once the tornado gets faster than 72 miles an hour, it becomes an F2 scale. If it's exactly 72, it's an F1. The second it gets to 72.1, it jumps up to an F2. And then from 72 to 112, it's an F2. And then after 112, so 112.000000001, then we jump up to an F3. So the second it's anything more than 112, it jumps. With an F3, it jumps up to an F4 once you get to past 157. Then once it gets past 206, it jumps up to F5, and F5 ends after 260. I'm not sure what we would do if the tornado got faster than that, because I never heard of an F6, but who knows? So, this is a basic kind of piecewise function. It's called a step function. You're kind of at the same y value, and then once you get to a certain x value, you jump up to the next level. Your letter grades in school are based on this. You start at anything from 0 to 59.9, you have an F. Once you get up to 60, then you end up with a D minus. Once you get to an 89.9, you've got a B plus. The second you get to 90, you jump up to an A minus. All the way up to 92.9. Once you get to a 93, you jump up to an A. Okay? So your score, your letter grades are piecewise, are step functions like this. You're at an A for a while, and then you jump up, or then you jump down to an A minus. You're at an A minus for a while, you jump down to a B plus. So that's how we calculate your grades, is with a function like this. Okay? Here is a little bit more complicated kind. This one actually uses slanted graphs, slanted lines. This graph has 2 segments to it. From -4 to +2, you're going to have one graph. And then from +2 to +4, we're going to have another graph, -2x. Anything less than -4 and anything bigger than +4 has no place. So we can't graph it. It'll be undefined. So if I tried to plug 7 into this, I couldn't, because there's no rule that tells me what happens at anything bigger than 4. There is a rule that tells me what happens between -4 and 2, though, and that rule is you plug it, or you take the number and you subtract 1 from it. also a rule that says what happens between 2 and 4. If you're plugging a number between 2 and 4, you're going to take that number and you're going to multiply it by -2. Okay? So this problem wants us to answer 4 questions. It wants us to talk about the domain, what numbers we're allowed to plug in. It wants us to plug 4 numbers in and see what happens. It wants us to graph that equation, and then it wants us to say whether or not the graph is continuous, or whether or not it is in one solid piece. Okay? So let's talk about the domain. What is the smallest number that I can plug into this function based on this right here? What's my smallest x value in these inequalities? What's my smallest of these 4x values? -4, right? What's my biggest x value? +4. So my domain goes from -4 to +4. Those are the only numbers I'm allowed to plug in. If I plug in anything other than that, my answer will be undefined. It'll be like, what would happen if you clicked the wrong thing on one of those CAPTCHAs? That would never happen. No one would ever do that 18 times. So we've got a -4 right here. That's our lowest value. We've got a +4. That is our highest value. -4 to 4 is our domain. There we go. Our formula. We have 2 formulas here. We need to know which one to plug them into. So to evaluate, we're going to take the number -3, and we've got to decide, is -3 between -4 and 2, or is it between 2 and 4? Okay? If it is between -4 and 2, you plug it into the first part. If it's between 2 and 4, you plug it into the second part. If it is not in either of those, you plug it into nothing, it doesn't fit. Okay? So let's start with Luna. What would I get if I plug, let me answer the phone real quick. This should be fun on video. Hello?
What?
Yeah, I'll send it. Yep. Evan, Shauna needs you in the office. Okay, so, Luna, if I plug -3 in, would I plug it into the top function or the bottom function? In the top one. Because -3 is between -4 and 2. So I plug -3 in, and Sam, what would I get? -3 minus 1.
-3 minus 1 would be
-4. So f of -3 equals -4. Okay, with the number 2, will I plug I plug 2 in, does it go in the top one or the bottom one? And that's a bit of a trick question.
Can they go in either one? No.
There's a spot for either one, but you want to go with the one with the equal to sign.
The one with the equal to sign?
So this one doesn't have an equal to sign, this one does. So you plug it into the bottom. So what would 2 times -2 be? 4. -4, right? So f of 2 would be -4, and you want to plug it in the bottom one because if there's 2 numbers with the same number, you go with the one with the equal to sign. So 2 times -2 would be -4. Okay, Max, let's do 4. Does +4 fit in the top or +4 fit in the bottom?
Bottom.
Bottom, right? Because 4 is between -2 and 4. So what would 4 times -2 be?
What?
4 times -2.
-8.
Finally, Jace, you get the tricky one.
Yeah.
The number 5, is it between -4 and 2? Does the number 5 fit right here?
Yeah. No.
No. Does 5 fit here?
No.
No. It doesn't fit anywhere, right?
Yeah.
So 5, because it has no home, it is undefined, no solution. So f of 5 is undefined. What that would look like on the graph is on the graph at 5, there will be nothing on the graph. There will be no mark on the graph for 5. That's because we can only use numbers between -4 and 4. If we plug in anything bigger or smaller than that, there will be nothing for us. It's undefined. Okay? Just like you cannot plug in a wind speed of more than 260 into the Fujita scale, because the Fujita scale doesn't tell us what happens there. There's no such thing as an F6. You also can't plug in a situation where there's no wind, because then you have no tornadoes. So only certain numbers make sense in tornadoes, only certain numbers make sense on this. Okay? So we have 4 answers. F of 5, we have no answer because 5 doesn't fit here and 5 doesn't fit here. Okay, now we're going to graph. Graphing these, there's 2 different ways to do it. There's one way to do it if I have numbers on both ends of my inequality. I have that here, I have that here. There's another way to do it, which I'll show you after this one. If there is an open-ended inequality, we're going to have arrows instead of points. So this function right here, what I'm going to do to graph, I'm going to take this number, I'm going to plug it into that function, I'm going to get an answer that will give me a point. Then I'll do it with this number, that will give me a second point. I will connect them with a line. Then I'm going to do the same thing with these 2 numbers. Other than this one's going to have an open circle, these 2 will be closed. Okay? So we'll have 4 points connected with 2 lines, that'll be my graph. Okay? So let's plug in -4 and get a point. Let's plug in 2 and get a point. We'll plug in 2 into the second function, we'll get a point. We'll plug in 4 into the second function, we'll get a point. So Gunnar, -4 minus 1, what would I get?
-5.
-5. So -4, -5 is this point right here. Next, Kate, 2 minus 1.
1.
So I plug in 2, I get 1. That is my second point. 2, 1. That one has a circle because I have an equal to sign here. I connect those with a line. So if I have endpoints on both, I have 2 lines or 2 circles. This one's closed, this one's open. Gonna do the same thing on the bottom. I'm gonna plug in 2 here, and Shaylee, 2 times -2. -4. And Kayla, 4 times -2. -8. So I'm going to have 2 more points. 2, -4. And that's going to be closed. And my second point, 4, -8. Also closed. And I connect those with a line. So here's a point, or here's a line segment, here's a line segment. That is my graph, okay? This graph right here wants to know, is this continuous? That's our last question. Continuous means it's one single piece that has no holes and no jumps. You can draw it in one piece without picking up your pencil. I'd go from here to here. In order to get down here, I have to pick up my pencil and start over. So this is not continuous. So the answer is this continuous? No. If I wanted it to be continuous, I could take this piece, I would pick it up and move it over here, I would fill in this hole, and continue like that. So that's what it would look like if it were continuous, but it's not, because I have a jump from here to here. The reason continuous is important is the rules of calculus say you are not allowed to do anything with calculus unless your function is continuous. So I am not allowed to do any calculus right here because it's not continuous. The rules of calculus don't allow that. So it wants you to know what continuous means so that you know in the future when you go to take calculus that you can't do anything with calculus right here. Okay? So continuous just means it's a single piece, no jumps or holes. Okay? That's what that's going to look like if you have a double-sided inequality or a triple inequality. Let's look at what it would look like if you had a open-ended inequality like you might in delta math. Okay? So I'm going to pull up one that you can see. Delta math's pretty easy to graph as long as you know what you're doing. So I'm going to show you kind of how to do that. So in delta math, you can do one just like we just did. Plug in -2, you'll get a number out. That'll give you a point. You click on the graph, you make that point, you figure out what your second point is, you click and drag. Let's say those are the 2 points we want. Let's say we want one of them to be open-ended. So I would click a closed circle. If you click the ending again, a line will, or an arrow will appear. So you pick a point, you click and drag to get the next point, and you can change the circles to open, closed, or arrow. So you just click it until you have what you want. Okay? That's what you would do for a situation like this, where you have a number on the left and a number on the right. If you do not, however, you might have something that looks like this. It has x is less than -5, that's what's happening on the left. And then you have x is greater than 1, that's what's happening on the right. So we're going to need to make 2 separate graphs, and these ones, because they're open-ended, instead of circles, will have arrows. Okay? So, this one right here, x is less than -5. Okay? X is less than -5. What we're going to do is we're going to plug in -5. -5 times -1 is 5, minus 3 is 2. So -5, -2 would be my first point. So -5, -2, that point is right there. Then the slope of my function is -1. That's the number in front of my x. Normally, I would go down 1, right 1. But on the left side, you're going to need to go backwards to the left. So instead of going down 1, right 1, I'm going to click and drag. I'm going to go up 1, left 1. And that's because on the left side, you have to go backwards. So down 1, right 1 is forwards. You reverse that. Up 1, left 1 is backwards. And that will give you my second point. So you plug in the number to get the first point. You use the slope to find the second point. This slope is down 1, right 1. So backwards is up 1, left 1. I also need a closed circle here, which I have, and I need an arrow on the left. So that is my first graph. Okay? My second graph says starting at +1 and going to the right because it's greater than, my formula is -x plus 7. So I'm going to plug in a 1 here. I will get -1 plus 7 is 6. So 1, 6. So there's my first point, 1, 6. This one is greater than, so I'm going to the right. I'm going to go up 1, right 1. Sorry, this one's negative, so I'm going to go right 1, down 1. Or down 1, right 1. And I have an open-ended inequality, so I need an arrow instead. Last thing I need to change. I do not have an equal to sign here, so at 1, I need an open circle. So let's go through that one more time. Plug in -5. -5 times -1 is +5 minus 3. I I get the point negative 5, negative 2. My slope says negative 1. So I'm going to go backwards. Instead of going down one, right one, I'm going to go up one, left one. That gives me my second point. I click and drag. And I change my point to an arrow. That's my first one. Second one, plug 1 in. That gives me 1, 6. That's going to be an open-ended circle. Then to get my second point, I go down 1, right 1. Click and drag. And I change that point to an arrow. And that is my answer. Let's see if it says I'm right. Oh, what did I do wrong?
Extra point.
You just made it an arrow, you didn't add a second dot.
There's
Oh,
an
okay.
extra.
So, it is right, it just, for some reason, was being annoying. So, yes.
Would your y on the first one be a 2 instead?
Not a negative 2.
Oh, that's what it is. Yes, it should be negative. Yep, sorry, it should be positive too. Good catch. Good catch. Okay, so that's what you would do. Open-ended inequalities, you need arrows. Closed-ended inequalities, you need circles. So you'll need to use your slope to find where the arrow's going. Okay? Anyway, that is your homework for today. You've got about 12 minutes to do it, or to get started on it. It's the 2.1 part 1 in Delta Math. So get that going, and when you are ready, you can turn it in. You've got all weekend though, it's not due till Tuesday. And what you can do is also Monday